Again, welcome to Mathematics 200 Calculus. In this lectures, we're going to use the derivative, and we are going to use the derivative to find the rate of change. So we have seen how derivative is used to determine slope. Also, derivative can be used to determine the rate of change of one variable with respect to another. Applications involve the rate of change occur in different fields. For example, population growth rate, production growth rate, water flow rate, velocity, and also acceleration. So a function S that gives the position relative to the origin of an object as a function of time t is called, again, a position function. For example, we know rate is equal to distance divided by time. So the average velocity is change in distance over change in time. Now we have a question here to find the average velocity of a falling object. So a billiard ball is dropped from a height of 100 feet. The ball's height s at a time t is the position function s equal to negative 16t squared plus 100. This is the position function, where s again is a measure in feet and t is measured in seconds. Find the average velocity over which of the following time interval. So here we want to find the average velocity between the interval of 1 to 2, 1 to 1.5, and 1 to 1.1. So here we are going to use a derivative. Now first, for the interval 1 to 2, the object fall from the height of s at 1 is minus 16, 1 squared plus 100, which gives us 84 feet to a height. Then s at 2 will give us minus 16. Again, we have 2 square plus 100, which will give us 36. Now, to find the average velocity, it will be 36 minus 84 divided by 2 minus 1, which will give us negative 48 feet per second. Now, for the interval 1 to 1.5, we also find s at 1.5, and we substitute 1.5 for t, which gives us 64 feet. We already know the one substitution from our previous question. So here we are going to have 64 minus 84 over 1.5 minus 1. When we plug in 1, we get s at 1 is 84 in our previous question. So this will give us minus 40 feet per second. Next, we have 1 to 1.1. So s at t, we substitute t for 1.1, and we get 80.64. We know 1 will give us 84. So we have 80.64 minus 84 divided by 1.1 minus 1, which gives us negative 33.6. So now we should know that the average velocities are negative, indicating that the object is moving downward. Again, the question said the object falls from the height, so it's moving downward. That's why it's negative. Now, in general, if s equal to s at t is the position function for an object moving along a straight line, then the velocity of the object at time t is, we have the limit dt approaches 0, then st plus dt minus st over dt, which will give us the derivative of s at t. So here we say, in other words, the velocity function is the derivative of the position function. So now instead of here, we substitute the t to find again the s, then we divide the s by t. We can straight ahead find the derivative of the function. So for example, here we have at time 0 seconds, a diver jumps from a platform diving board that is 32 feet above the water. The initial velocity of the diver is 16 feet per second. When does the diver hit the water? And also, what is the diver's velocity at impact? So here we know the formula and the equation s at t equal to negative half, because it's 32 feet, 32 t squared plus 16t plus 32. So S at t will give us negative 16t squared plus 16t plus 32. That will be our position function. Now we need to find the time t when the diver eats the water. So we let S equal to 0 and solve for t. So the t will give us, by factorization, to give us negative 1 or 2. Now, because t, the time have to be greater than or equal to 0, we are going to choose 2 seconds. Now, to find the velocity at time t is given by the derivative of the formula. So we know S at t. We take the derivative of S at t, we get minus 32 plus 16. And which is given to us minus 32 plus 16. Derivative of 32, constant value is 0. So from here, we will say that the velocity at the time t equal to 2 will give us the derivative. So here we can see that with the position function, if we are looking for velocity, we can find the derivative of the position function. Then we substitute the t value. So that gives us minus 48 feet per second. So that will be the conclusion of these lectures. Here we are learning the rate of change. Again, rate of change, we don't have to use the derivative, but we saw that, again, we can also use the derivative to solve the problem.